Hi, hello. Today I'll be practicing my maths by doing some interview questions, specifically geared to the Oxbridge kind of material. Um, the questions I'll be attempting today, they are from a Discord server that I found them in, and hopefully I will try to remember to link them down in the description. But I will show you quickly what it kind of looks like. This is the file. The last question is a computer science question, which I will very much ignore. And I will see how much I can do in one sitting of all these questions. So I already put some of them into Miro. So just to check that I'm recording, yes, I am recording. I do need to make it smaller. Oh, I just realized that you probably didn't see me going through the file. Yes, this is the computer science question that I mentioned. So, for instance, this question is from Trinity College. Amazing, a great start. One of the most competitive maths colleges at Cambridge. And I'm not even applying to Cambridge, I'm applying to Oxford. But yeah, so I will get started. These are questions that I found them today. So um, I am kind of going through them with a very new mindset. And this question specifically, it's very odd. I've never seen something like that. I'll read it out. This question has two parts. Part A, sketch a graph of x squared y squared is equal to x squared plus y squared. Then it has a part B. I do not know what the black star denotes, but I suppose it might mean that it's of greater difficulty, but do not take what I've just said with certainty. Hence or otherwise, sketch the surface defined by x cubed, y cubed, z cubed equals to x cubed plus y cubed plus z cubed. Now, this is a very odd question, and one. So right now I'm in interview mode, so I will think out loud. Um, when I don't really know what to do, I will try to state the obvious. So I will try and I'll deal with part A first, and I will make some observations. So 1A, my what I need to sketch is x squared y squared is equal to x squared plus y squared. Now let me think of the things that seem to be obvious. So so the origin 0 0. So if x equal to 0 and y is equal to 0, 0 squared, 0 squared, 0 squared plus 0 squared. Now, this is clearly satisfied. Um, Therefore, I can say that the origin 0 0, or the point 0 0, is in this sketch, or is part of the graph. So perhaps this phrasing is better. Is part of this graph. Um, Now, what else can I say? I can say that this is a symmetric function. One that has a symmetry in the line x equals to y. And that's because if I replace all the x's with y's, it wouldn't change the question. So this is the same as me saying y squared x squared is equal to y squared plus x squared. This might not be it might be a very trivial observation, but it is quite an important one. And I can also say, that reminds me of, if xy is a solution, or satisfies, to use better words, satisfies this, then minus xy, what else? X minus y, and minus x minus y also satisfy the above expression. And I think this is a very obvious observation, but I am trying to sketch something quite complicated. So it is something I think good to keep in mind. What else can I say? Um, well, I'll draw my axis. I guess one of the benefits of symmetries is that if you know how it's going to look, let's say in this quadrant or in these two quadrants, and you know it's symmetric on both sides, then if you know how the graph looks like here, you automatically know how it would look like here. So not only this expression is symmetric in the line y equals x, is also symmetric in, let me write down all the symmetries. It's symmetric in the x-axis, oops, y-axis, and of course the x equals to the line x equals to y. I guess this is very important because now I know, if I know how the graph looks like here between y equals to x and the y-axis, I automatically know how the graph will look like everywhere else. So just to recheck what the question is. Okay. I do not like how I drew this. So I'll do it one more time. Mm, what else can I say? If I Are there any ways I can rearrange this expression in a way that might actually help me? Um, Not sure, but let me try to plug in some values like x equals to 1. If x equals to 1, then y squared is equal to y squared plus 1. This clearly doesn't work because there is no value of y such that this is satisfied. If x equal to 0, y squared. Okay, if x equals to 0, then y must be 0 as well. Okay. If x equals to y, then we have x to the 4 is equal to 2x squared, which means that x squared is equal to 2, x equal to plus minus root 2. So what is interesting of what I just did is that now I know um, at which point or which coordinate x and y are both the same. Okay, it seems like I am not doing much progress. So the hard thing about this is that I am by myself, so there is no one to actually correct me, and this is kind of going to be very, very pointless if I am not given any directions, and I don't believe there are any hints. And I hope everything I've said so far is coherent. So I know the the origin is a point satisfies um, this. Um, what else can I say? Well, if I can also write this as xy is equal to plus minus. square root of x squared plus y squared. And x squared plus y squared is just a circle. And square root of that is a semicircle. So still no good. I could think of this as oh, I could perhaps do this. So x, I can rewrite this as, my pen works. Seems to not work. Okay. X squared minus x squared y squared plus y squared is equal to 0. I can say, just to check, x plus y squared is x squared plus y squared plus 2xy. So this is the same as x squared plus y squared minus 2xy minus, oops, minus, um, why is this not working? Okay, it works now. Minus x squared y squared, which is the same as 2 minus xy. So I'm not seeing anything important or cool appearing. So I do still think I am going the wrong way. Um, what else can I say? There's definitely some clever manipulation somewhere. Well, what I could try to do is to complete the square. For some reason, my mirror on my iPad is giving me issues, and that's kind of annoying me. And nope, that's not what I wanted to do. How do I fix this? I'm going to have to change to mirror on my browser. Okay, so just to recap, um, this is going to work. I can think of this. Okay, I'm back. Yeah. Well, I know that the line x equals to y. No. I need to find, like, I need to like plug in random values and see um if there is something I can do. Okay, for instance, let me get rid of the axis. I am not yet at that stage where I can actually draw this. And I'm a very much a mediocre mathematician, so this might not be as obvious as to other people. I can say, for instance, if x is equal to 2, then you have 4y squared is equal to 4 plus y squared. Is that correct? Yes. That means that 3y squared is equal to 4. It's not working. And therefore y is equal to plus minus 2 over root 3. Okay, that's progress. And if I say x equals to 3, then we have 9y squared is equal to 9 plus y squared, which means 8y squared is equal to 9. Y, oh, very ugly y. Again, very ugly y. Um, y is equal to plus minus 3 over 2. Okay, interesting. And I'm going to go on until x equals to 4. 16y squared minus y squared is equal to 16. And therefore y is equal to 4 plus minus root 15. Okay, so there's kind of a pattern. So the numerator is always going to be what the x value is, and the denominator is root 1 minus what the, sorry, is going to be root 1 minus x squared. So for instance, root 8 is um, actually is 1 plus 3 all squared. No. Okay, no, I'm going this the wrong way. It's root 8 is 3 squared minus 1 and you root that. Okay, so that means my denominator is going to be x squared minus 1, which is perfect. It's a difference of two squares. I don't think that's relevant. So if x is equal to alpha, my y value is going to be alpha plus minus alpha over alpha squared minus 1. Okay. So I've done some progress. That means I can start plotting x, y, some of this. So I know it goes to the integer. I know at 2 it is 2 over root 3, so it's roughly 4/3, which is, oh no, 4/3, is it 4/3? Yes, it's 20 over 15 roughly. And yeah, so it's still more than 1, so it's going to be somewhere here. And at 3 it's 4 over 15. Oh no, it isn't. My iPad keeps on bugging out, and this is very annoying. So yeah, I am getting very angry. Okay. This is becoming very annoying. Okay, so at 3 is 3 over 2, which I suppose if root 2 is roughly 1.41 times 2 is 2.8, 3 over 2.8, that is still more than 1. Then x equals to 4, you have 4 over 15. 15 is just shy of 4. That means it's still above 1. So it's always going to be roughly more than 1. And also, if I know that this is true, then this also must be true, which means that this also must be true, and this also must be true. And I think it would be very interesting to see what happens between what -1 and 1. So I'll be doing that. For instance, if let's let's say x is equal to half. It means a quarter y squared is equal to y squared plus a quarter, which means that's y, this is going to be a negative number, minus 3 over 4y squared is equal to what quarter? It means y squared is equal to minus a third, which is not possible unless we, because we're strictly talking about real numbers, which therefore means that between 1 and minus 1, there, there doesn't exist a value. That means I need to either take limits or not. So let me think of a number that is very close to 1, but it's not quite 1. So for instance, 1.1. So x is equal to 1.1. 1.1 squared is what? 1.2, 1.21? That might be wrong, but it looks correct. Because 11 squared is 121. So yeah, that's correct. 1.21 y squared is equal to 1.21 plus y squared. Means 0.21 y squared is equal to 1.21. Y squared is equal to 1.21 over 0.21, which is equal to 121 over 21. So it's actually quite a large number compared to everything else we've gotten so far. So I know there's going to be an asymptote at 1 and minus 1. And I'm going to assume by symmetry, if this and this are 1 and minus 1 respectively, there's also going to be an asymptote here. Okay, so I am doing some progress. Okay, this is not as bad as I was thinking. It is. I am still performing very poorly. Just I would like to remind everyone that the time is 9. So and I just came back from school, so I'm pretty much intellectually fried. And as J.H. Hardy says, that the limit for a mathematician is 4 hours of creative work. And as I always say, I'm well past that time, uh, that time limit at least. So let me try a smaller value that's close to 1, 1.01. And actually, I'm just going to work this out very quickly. 201 is ex squared is equal to 10201. 4 zeros. Okay, so this is what x squared is. It means 10201 y squared is equal to that plus y squared. That means y squared is equal to 1.0201 over 0.0201, which means that y squared is equal to 10201 over 201. Is that correct? Yes, that seems to be correct. And yes, so the closer, I'm going to get rid of these points actually. They're pretty annoying. Okay, so I've got asymptotes. Okay, that means if I change color, it's going to be something like this. By symmetry, it's going to be something like this. And again, by symmetry is going to be like this. And by symmetry is going to be like this. And I guess as x tends to infinity, I can take my earlier expression of, what was it? Y is equal to x over plus minus, at least I'm just thinking of it about one instance in this scenario, x squared minus 1, as So I'm gonna take limit of x as x tends to positive infinity is going to be, well, x is going to tend to infinity. Infinity squared. I mean, this is just close to this, which is for very large numbers almost 1, but x is always going to be greater than this. Therefore, this value is going to tend to 1. And by symmetry, this is going to be the case for all quadrants. So even when it so if this works for here, it's going to work for here, and similarly the other quadrants. So I'm gonna redraw the sketch very nicely. That is a lot of work and a lot of me struggling. I'm going to use this, and my thing is frozen again. Okay, now it works. I am trying my best to sketch my best graph. X, Y. So we know there is going to be asymptotes. I'm gonna change. I wanna be fancy. I'm gonna change colors for the asymptotes. Gray looks great. So, okay, now perhaps they can't. Gray can't be seen. This is 1, and this 2. Okay, that this should be fine. So it should look something like this. I should probably check on Desmos. How do I exit full screen? Okay. So this is part A. I'm going to be checking. Probably I'm gonna have to resort to asking AI because I have no clue what the answers to this are. Hopefully, I'll figure them out as I go along. Can Desmos um sketch non-functions? That's if not, I'll just go to GeoGebra. Okay, yes, that looks great. So yes, asymptote of 1. I would say I got the question right. Yes, nice. Um, I would say that perhaps I got a bit lost here, trying to find some efficient or clever way to rearrange the expression, which perhaps may not have existed. I just realized I did spend roughly what 20 minutes doing this. So yeah, I am pretty tired and pretty rusty at this. Okay, so next part. So I'm gonna move the next questions slightly. Hopefully those questions are nicer. But yeah, okay. So this is clearly something 3D. Because we're introducing a new variable z. Okay, I'm going to state the obvious things about this expression. So now, when I do the asterisk, I am referring to the other expression. Okay, so I'm going to rewrite the expression. What was it again? X cubed y cubed z cubed is equal to x cubed plus y cubed plus z cubed. Okay, cool. Now, what are the first obvious things I can think of? Okay, obvious things or trivial things. I can change. I can change x to be y, y to be z, z to be x, and the question wouldn't change. That means there is a symmetry between all of them, between all the axes. For instance, x. So, is there a name for it? Like, wait, let me make this full screen. Uh, Permutationally symmetrical. Is that a thing? I'm not sure. I have to check. But yeah, so x could be. You can change around. I can say this. You can. Uh, okay. You can change around x, y, and z, and your expression wouldn't change. What else? Now this is if x, y, and z are do satisfy x, sorry, asterisk, then minus x, minus y, minus z also do, and that's because this would become minus cubed, minus y cubed, minus z cubed, which is just equal to minus x cubed minus y cubed minus z cubed. These two, one of the two minuses will turn into plus. So this whole expression is negative. X, y, x cubed, y cubed, z cubed is equal to I think it's my palm which is on my iPad and it's preventing me from doing the work. X cubed plus y cubed plus z cubed, and these minuses kind of cancel out, and we get back to our original statement. Asterisk. What else can I say? I could, for instance, reduce the powers and talk about yeah. So okay, so perhaps, as I said, I can reduce the powers. So let's say u no a b c is equal to a plus b plus c, something like that. I am thinking of doing contour lines, however you say them. I'm not sure exactly. Um, I can, for instance, fix z. Fix z equals to, let's say, 0. Oh yes, that's actually smart because I can kind of see um, where each line intersects. And if z is 0, that means that x cubed is equal to minus y cubed, which means that x is equal to minus y when z equals 0. Similarly, when um, x equals to 0, you have this relationship, z is equal to minus x minus y. And when y is equal to 0, you have x is equal to minus z. Okay, that's actually quite helpful, I think. So I know where each axis is going to intersect. Okay, so let me fix z equals to k. K is an integer. Very nice z. Okay, so k equals 1. So we have x cubed y cubed is equal to x cubed plus y cubed plus 1. And this is a 2D surface. So, and oh hell, I think this is going to be a hell to kind of sketch. It is similar to our first part. So I might have to take inspiration from there. How on earth am I meant to do this? This is very similar if you ignore the one there to your previous part. So these two parts might be connected somehow, somewhere. Um, oh, I am staring at this and I can't really think. Mm, well, surely, this is going to look differently. This is not. This doesn't have the same symmetries. It does have a symmetry on the x equals to y and x equals to minus y. Does it? Not minus y, perhaps. Um, quite a interesting problem. So if k is equal to 2, you have 8x cubed y cubed is equal to x cubed plus y cubed plus 8. Um, so I'm thinking of the 3D shape. This is my x, this is my y, this is my z. That if when z is 0, when z is 0, I might have to come back to this one. Yeah, I'm going to move on to a different question, and probably this is the first time I'm seeing something like this, and I'm pretty mentally fried. Okay, I'm not giving up. I'm just going to move on to something I can try and attempt. Okay, second question. I need like 5 seconds to breathe. Okay. Find all n such that 4 to the n plus 1 is divisible by 25. Okay, this seems to be a much simpler question, and I'm probably going to regret saying this. Okay, first of all, I presume that n is an integer. Um, because it has to be divisible by 25. The closest thing to 25 that is a power of 4. So, for instance, 4 to the 2 is 16, 4 to the 3 is 64, and 64 plus 1 is 65, which is 50 plus 15, so it isn't divisible by 25. To be divisible by 25, you must satisfy this two condition. Actually, let me write it formally. 4k to divide 25, k must divide 5, and k No, no, sorry, sorry. That's not how you write it. Um, sorry, no. For 25 to be, it's the other way around. 25 to divide k. Um, 5 must divide k, and what are the prime factors of, and you, well, actually, you have to, you need to have two fives. So 5 squared must divide k. Okay. So 4 to the 4, which is what? I should know this. 256. 257 is very much not divisible by 25. So I know that um, this expression for n plus 1 must be divisible by 5, by two fives, because 25 is a perfect square. Okay, maybe I can try use modular arithmetic. So 4 is minus 1 modulo 5. I guess let's consider this. And 4 to the n is minus 1 to the n modulo 5. Okay, that means 4n plus 1, okay, I'm getting somewhere, is minus 1 n plus 1. So if n is odd, then for n plus 1 is modulo 5. And I think this is a very good example, a 65 one. But what we want is this to be modulo 25 0 for it to be divisible. So I'm going to repeat this process again. With some empty space here. So we want 4 is 1624 is the nearest multiple. So it is 1 mod 25 because 4 times 6 is 24. That means 25 is 1 more than a multiple of 4. I hope that makes sense. This implies that 4 to the n is 1 to the n mod 25, and we know that 1 to the n is just 1, so 4 to the n plus 1 is 1 plus 1 mod 25. 4n plus 1 is 2 mod 25. So what this seems to insinuate is that actually there is no such n that divides, that is divisible, such that 4 to the n plus 1 is divisible by 25. And this might be very much, I might be missing something very important. Or my assumption that n, my assumption that n must be an integer is clearly going to have to be true. So am I missing something? Is, well, my first statement, this one here, is correct. This implies this, which implies this, which implies this. Okay, I've shown by modular arithmetic that this is not true. And I think I'm satisfied with this. I think this is very much good evidence. This might be a very good proof. Well, if interviewer, if it wasn't an actual interview, I would probably get cooked by now. So the there is no such there doesn't exist an n such that 4 to the n plus 1 um, is divisible by 25. Okay, I might have to check this out on some browser or probably Discord. Okay, uh, I can't. I might be very much correct because modular arithmetic. I am trying to paste. I'm just going to do this. Okay. Oh no, no, for 2 the n. Otherwise, the question would be much more simpler. Okay, so that kind of seems to be. Uh-huh. Oh yes. Okay, okay. So I am very stupid because this doesn't work. Okay, I have to retry this. I kind of understand how this is done. Okay, I'm gonna try again. I was very much convinced that there is no such thing, but from now on I should not think like that. Okay, so from what I understand, I'm going to have to analyze instances of n. How do you do this? So we want to set up a congruence 4 to the n plus 1 is 20 is congruent to 0 mods 25, which implies the 4 to the n is minus 1 modulo 25, congruent to minus 1 modulo 25. Now I need to analyze powers of 4 to the n. So when n is equal to 1, and congruence 25, I'm kind of drawing a table here. 0, it's 1, it's 1, 1 is 4, 4, 2 is 16, 16, 3, 64, and I think we already did this. 15, yes, I'm gonna try again. 4 is 256, and 250 is divisible by 25 with remainder 6, and 256 times 4 is 1200. Oh, actually, this is this actually works. Okay, so n equals 5 works. We've got a solution. So why didn't it not work then? I'm gonna try to find another one. This might be long. 4096, which 4075 is divisible by that, by 25. This is modular. This has it's congruent to modular 21. Um, I'm gonna go up to 10. You know what? Because you know what? I've got the time, and I'm not in a real interview. Thought I shouldn't be thinking like that. 7 times 9. See, I don't know my times table. This is not great if I want to apply to Oxford. Well, I've already applied. It's too late now to go back. 7 times 9 is 63. Plus 4, 7. And this is this. 28672. It's very close to 28675. That means that this is minus 3. Modulo minus 3. Okay. Okay. Not too bad. So what's so special about 5? What is so special about 5? Um, that it has modulo minus 1, perhaps. Sorry, that is congruent to modulo minus 125. Mod 25. I am just speaking gibberish right now. This is so annoying. I'm going to be rewatching this video and I'll be so embarrassed of myself. How can I think of this? Finding all n. I've stated the obvious there. Well, 5. Well, for instance, if I try 4 to the 10, 4 is what modulo 25 is 4 mod 25. 4 to the n is 4 to the n mod 25. I'm not going anywhere with this. I suppose I might need a hint, but I think me looking up that I'm wrong is enough of a big hint. Well, the good thing about this is that the more I think about this, the hopefully the closer we get. So modular arithmetic, my approach to modular arithmetic is definitely a good one. I am curious to see where this might be. Oh shit, that's not true. That's not true. 4 is not modular congruent to 1 mod 25. That is not true. Did I seriously dude? Oh, and I was so convinced I was correct. This is silly. This is a See, this is why I'm not gonna get into Oxbridge, because if I do silly mistake like this is not true. And in fact, is that I just realized this. It's embarrassing. Oh my god, did I seriously say that 4 is congruent to 1 mod 25? Fuck. Okay. Okay. That was very stupid. That's insanely stupid. Okay. I do not want to work out powers of 4 by hand. Well, so I know that 4 to the 5 is congruent to 22 minus 1 mod 25, then 4 to the 5n is congruent to minus 1n, then n must be an odd number such that for it actually means m instead of n. 4 5m plus 1 equals 0. Okay, so all numbers which, so if n can be written in the form of 5m, okay, I just didn't see that. Okay, sorry. If n equals to 5m, okay, that works. Well, I wonder if 4 to the 10. Oh no, this is true. Where m is an odd number. So this is not true. So n must be, you can write it as 2k plus 1, n is equal to 10k plus 5. That's my final answer. If n can be written as 10k plus 5, then we have all of our n such that 4 to the n plus 1 is equal to 25. And I glanced at it. It might be that. Yes. Okay, I am not super stupid. Okay, I am almost on an hour of doing this. Okay, perhaps I'm gonna do one more, or probably I might have to upload this bit by bit. But yeah, this is quite good. I really enjoyed this. This was very fun, and I've learned a few new things. Okay, that's very cool. And I guess I can change the question up, and I can do this exact same process. Okay, that's amazing. It's amazing to know. Um, because my computer may not be able to handle like an hour of video, I may have to do it parts by parts. But yeah, I still know how to do the last question, and that's probably going to be something I will have to look up. But yeah, I think for for three questions, I'm going to consider the surface questions as a question itself. So three questions wasn't that bad for an hour of me doing this at what is now 9:30 p.m. And I do think I'm going to do two more, but in a different video. But yeah, I mean it. Just a few quick ending reflections. When it comes to this question, I really enjoyed the first part. Stating the obvious is something that I've learned when it comes to like other kind of graphs, that it's very important, and I did end up getting the graph right. When it comes to this question, I need to be careful of not making silly mistakes like this, and it is just embarrassing the fact that I've glanced instead at even called it certain, and yet this is clearly not certain and this is clearly wrong. But yeah, I like how I structured my answer here. But ignore this. This is just before I had an epiphany. But yeah, that looks fine. Okay, nice. I will probably end it here. If you did see me struggle all the way to now. I think you deserve sending me an email and I will ship you chocolates. 'Cause why not? But yeah, this is very cool. I'm gonna crack on and do the next two questions.